Up until now, we've covered basic derivatives, basic polynomials, and then after that we covered what do you do when you have two functions multiplied by one another, you know, f of x times g of x, where they can be any old functions you want, and we knew what to do with that. In this section, we're going to learn how do we handle when we have two functions divided by one another. And you'll see that it looks really lengthy, and it is a little bit lengthy, but it's very bulletproof, and it's quite easy once you know how to do it. So, if you have two functions, let's say, one of these functions is f of x, and the other of these functions is g of x. So these could be anything. This could be x squared, this could be x plus 2x plus 5. Later on when we get into trigonometric stuff, this could be sine of x, this could be cosine of x, could be any functions that you like. Then if you're going to take the derivative of what we call the quotient, so we'll have f of x divided by g of x. So we just take these two functions and divide them by one another, take the derivative, that's what this means. Then the way you do that is as follows. So let me close this parenthesis off, g of x. So what you have is the bottom function, g of x, times the derivative of the top function, f prime of x, minus the top function, f of x, times the derivative of the bottom function, g of x. And then you draw a big division bar over the whole thing, and the bottom is g of x. Now, just to make it clear, I'll put it in brackets, the whole thing squared. So this is what we call the quotient rule. You'll definitely see this in your calculus book. The notation might be a little bit different. I'm using the prime notation for derivatives. You can write it in terms of, you know, dy dx notation or df dx notation if you want to. But this is, I think, a little bit more clear about what you're doing. Really what you're doing is if you have two functions divided by one another, you take the bottom one times the derivative of the top one minus the top one times the derivative of the bottom one and divide the whole thing by the bottom one squared. All right, so we're going to do a few problems here and we'll see how to use it, but I'm going to give you a little sneak peek here. This quotient rule is really nothing more than the product rule that we learned in the last section in disguise. In other words, if you think about it for a minute, if you're dividing two things, you can rewrite that as a multiplication of the top times 1 over the bottom. It's like a fraction thing. F of x times 1 over g of x, they can be multiplied together. So if you do the product rule on those two things, f of x times 1 over g of x, you do the product rule, which is first times the derivative of the second plus the second times the derivative of the first. If you do that and simplify it, what you're going to get is this. So this is not really anything new. It's really just a little bit easier to follow in a bulletproof manner rather than using the product rule all the time on these guys when they're divided, because you have that fraction in there. So again, you need to memorize it because it'll make your life really easy. And you may have your own ways of memorizing it. The way I do it is bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. All right, so let's go and see how we apply this guy. I'm going to leave it up there on the board. And so for our first problem, let's say we have a function y is equal to 4t plus 5 divided by 2 minus 3t. So you see this is a quotient because we're basically dividing two things. The numerator is a function, this is what it is. The denominator is a separate function. So in this case we would consider f of x to be the top and g of x to be the bottom. So in order to take this derivative, what I'm going to advise you to do in the beginning here with derivatives is to write everything out and make it really explicit. If you start trying to take derivatives and do too many steps at once, then when you get a little bit better at it, it's probably okay. But in the beginning, if you start skipping steps and trying to truncate steps and save yourself some paper, then you're going to eventually make a mistake, get an exam question wrong for no reason. So the way I'm going to ask you to do it is the way I'm going to do it here, and this is how I write it down when I do it as well. So what I would write, y prime, right, so the derivative of this guy is the bottom 2 minus 3t times the derivative of the top, because we're working on this, bottom times the derivative of the top. So I'm going to write 4t plus 5. And I'm going to put a prime because I need to take the derivative of that, but I'm not going to take that derivative right just yet. Then I'm going to subtract the top times the derivative of the bottom. The top is 4t plus 5 times the derivative of the bottom from here. So I'm going to write 2 minus 3t. I'm going to put a derivative symbol there because I need to take that derivative. And I'm going to draw a giant fraction bar. And the bottom I'm going to write as the bottom square, 2 minus 3t, close it, and squared. So make sure you understand what I'm doing here, because after this it becomes pretty simple. It's the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function over the bottom function squared. So there's two things I want to point out before you actually solve this. The first thing is what I just mentioned a minute ago, is it bears repeating. You see, as we were doing this, I could have just taken this derivative here. It's so simple when you get good at it. I could just put the derivative here as I'm working along, and I could put this derivative in this step as I'm working along. And when you get a little bit better at derivatives, it's fine to do that, but I really recommend in the beginning to write this down, because you'll know what step you need to do next, you won't get confused, and if you do make a mistake, at least your professor will be able to see that you knew what to do. Even if you take the derivative incorrectly, at least they'll know that you knew what to do, which is super important for partial credit. So do yourself a favor, just use the extra line. Second thing is, you need to get in the habit when you see t's. Do not, before you take a lot of math, you write, the letter t like this. Unfortunately, it looks exactly like a plus sign. So get in the habit of writing your t's like a variable t with a little thing at the end like that and cross it off. Just practice about 10 times on your paper. Give it a little hook at the bottom. It's something that I never did until college, but it's something that really helps. And what that's going to do is it's going to allow you to be able to instantly see the difference between t and plus, t and plus, t and plus, okay? So let's go on to the next line and start working on this stuff. So we'll say y prime is equal to, we'll just carry this through, 2 minus 3t times. What is the derivative of this guy right here, 4t plus 5? Well, from our previous lessons, you should be able to convince yourself the derivative is just simply 4. Okay, the derivative of this constant is 0, and the derivative of the guy in front of the t here is just the 4. We'll have the minus sign, then we have to rewrite this again, 4t plus 5. And then the derivative of this guy is the same sort of thing. The derivative of this is 0, derivative of this term is negative 3. So we'll do that there. We'll draw a division bar, and we'll have 2 minus 3t squared. So we're making some progress. Let me go and switch colors back just to make it a little easier to read. Y prime. Now, let's just go ahead and multiply the 4 in here. So 2 times 4 is 8 minus 3 times 4 is 12t. All right. Now, do yourself a favor here. Your guys are good enough at algebra, you can decide how many steps to show. But just to make it absolutely clear, I'm going to keep the minus sign and do the multiplication. So I have negative 12t inside here, and then I'm going to have negative 15. If I tried to combine all of this with a negative outside, it's likely I'm going to eventually make a mistake, so I just choose not to do that. So I have 2 minus 3t, and I'm going to square it. All right, let's go down and just simplify a little bit more. So y prime, finally we have 8 minus 12t, distribute the negative, it'll be plus 12t plus 15 over 2 minus 3t squared. And finally, I think we're ready to write the final answer down, y prime. The 12t's cancel because negative and positive, and 8 plus 15 is going to be 23, so it's going to be 23 divided by 2 minus 3t squared. 23 divided by 2 minus 3t squared. Now, in the denominator, you do have this guy that's squared, and if you want to, you could expand that out. You could use FOIL and blow it up, but it's really not going to lead to any cancellations. It's not going to really simplify much, so you can just leave it in factored form, but it's really up to you. Truthfully, you have actually taken the derivative and gotten the answer here. Truthfully, this is really the answer. After you actually take the derivatives, you could theoretically leave it like this, but your teacher's not going to like that very much. You really should try to simplify it as much as you can and get down to where you can. So don't forget, when you have quotient like this, it's bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom quantity squared. We're going to do it enough times that I think we'll get the hang of it here, but it's very, very important that you memorize that because you'll be using it all throughout calculus for lots and lots and lots of different kinds of problems. So let's say for our next problem, we have f of x is equal to x over x plus 1. X over x plus 1. So let's take the derivative. So what we'll have is f prime of x will be the bottom, x plus 1, times the derivative of the top. I'm going to write the top and put the derivative mark to remind me to take that derivative later, minus the top times the derivative of the bottom, put that mark to remind me to take that later, over the bottom squared. So we followed our rule exactly. And once you do it a few times, you won't even have to refer back to that general rule. You'll just remember it. F prime of x is equal to x plus 1. What is the derivative of x? I think you can convince yourself from our previous lessons that's just 1 because there's a 1 in front there. And then you'll have a minus, and you'll have x. What is the derivative of this term? Well, the derivative of x is just 1. The derivative of the constant is 0, so it's quite simplified there. And we'll divide by x plus 1 squared. So now we're getting basically down to the answer at this point. So what we'll have is f prime of x is equal to, this is just multiplied by 1. So on the top I'll have x plus 1 minus x over x plus 1 squared. And so I'm finally ready to write the answer down. F prime of x is equal to, we'll have the x cancel out with the negative x, so we'll just have 1 over x plus 1 squared. So the derivative is 1 over x plus 1 squared. So again, bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And at that point, you just take those derivatives the way we've discussed already and flow through with everything else. So I've alluded to this before, but I want to make sure that you really understand. I'm going to kind of give you another little statement here just to make sure you know. This quotient rule is nothing new, okay? It's nothing any more complicated than what we've been doing before with the product rule. Let me show you a little more explicitly why that's the case. I'm not going to do a long proof or anything, but I'm going to just make sure you understand. This is the function we have. I'm going to rewrite it here. F of x is equal to x over x plus 1. Okay, what if we rewrite this? Remember, all division can be written as multiplication. So what if I rewrite it as x times 1 over x plus 1? I think you would all agree that these two things are the same thing. When you multiply these things together, you just get what we started with. But this is simply a multiplication, right? It's a product. And we already know how to take derivatives of products. So it would stand to reason that really you don't have to use this quotient rule at all unless you really want to. You can just always use the product rule. If you split it up like this, you would use the product rule of the last section. You would have the first term times the derivative of the second plus the second term times the derivative of the first term. I'm not going to go and prove it here, but when you do that, you're going to get exactly the same answer. In fact, if you construct a general function and do it and actually do all the math with the product rule, what you're going to find is that you can put it into this form. All right, so I guess what I'm trying to say is the quotient rule is nothing new. It's something that just comes out of the product rule. The reason we use it is because in practice, even though you might think, well, I don't really need to use it because I already know the product rule, in practice, when you have the division of two functions, it's just a little bit faster to say bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Because when you do this product rule, I'm not going to sit here and do it for you, but you're going to have a lot of algebraic simplification to get down to a good answer. So just take it from the teachers before you and the people before you that the product rule is important for you to know. Go ahead and use it, but don't get worried that it's something really new and different that calculus just jump up and throws at you, because it's really not. It's something that's always been there, and we're just rewriting it and using it for us. So let's ratchet up the complexity just a little bit, nothing crazy. But let's go and do this guy. We'll have y is equal to 3t minus 7 over t squared plus 5t minus 4. So I think you would all agree this is a quotient. We've got two things multiplied together, or divided by one another, I mean. So let's go and take the derivative. So dy with respect to t. And notice I'm using different notation. Here I'm going to say derivative of y with respect to t. Over here, when I have f of x, I'm going to say f prime of x. Over here, when I had y, I just called it y prime. I'm intentionally mixing notations to show you that they all mean the same thing. If you have y prime, it's the same as dy with respect to t. So I'm just going to do that occasionally just to kind of get you used to it. So what we're going to have is the bottom guy, t squared plus 5t minus 4 times the derivative of the top, 3t minus 7. Put a derivative mark to remind me to do that. Minus the top guy, which is 3t minus 7, times the derivative of the bottom, which is t squared plus 5t minus 4. Put the derivative mark to remind me to do it later. All divided by the bottom quantity squared, t squared plus 5t minus 4. And put a square there. All right, so now I just have to take the derivatives. But these are all polynomials, so they're really easy. So dy with respect to t is t squared plus 5t minus 4. What is the derivative of this guy here? It's just going to be 3. Because we just take what's in front of the t, that becomes our derivative. This guy, the derivative of that constant is 0. And we've learned how to do that in previous sections. Minus 3t minus 7. What is the derivative of this guy? Well, here we're going to have 2t. Here we're going to have 5. And here the derivative is just 0. So it just drops off. And we've learned how to take derivatives of polynomials before, so it shouldn't be a big surprise. Underneath, we're going to have t squared plus 5t minus 4 squared. So at this point, we've actually arrived at the answer. We're actually done as far as the math goes, but we really need to go ahead and simplify it. So let's go ahead and do that. Let's multiply the 3 in here. So we'll have dy with respect to t. We're going to have 3t squared plus, multiplying here, 15t, multiplying here, minus 12. I'm going to leave it in parentheses now just to make it clear that this came from this guy here. Now over here, let me leave the minus sign out just to make it absolutely clear. Let's do the FOIL that we need to do to multiply these together. So the first two terms is going to give us 6t squared. The inside term is negative 14t. The outside term is 15t. And the last terms is negative 35. There's no t there. So we'll just close it off. So you see why I'm leaving the negative outside and I'm doing the FOIL. Because if I start trying to do the FOIL and then take into account the negative out at the same time, I'm going to eventually mess up one of these signs. So I'm just going to make sure I get it right by doing it one step at a time. The bottom is just a rewrite. T squared plus 5t minus 4 squared. All right, so let's continue on. dy dx, or dt I should say, is equal to, let's rewrite this, 3t squared plus 15t minus 12. I'm going to take the parentheses off because now I'm going to distribute this negative in. Negative 6t squared. This guy makes a positive 14t. This guy makes a negative 15t. And this guy makes a positive 35. So I'm stripping the parentheses off because now I'm really going to end up adding all this stuff in the next step. And I just want to have those parentheses gone so I can see everything. T squared plus 5t plus, I should say minus, 4 squared. All right, now we're ready to write the final answer. dy dt equals. First thing you want to do is just add these guys together and just look for common terms. So we have a negative here, so we'll have negative 3t squared. Now when you have a long guy that you're really adding lots of terms, I put a little dot over the terms that I have added together so I remember that I've done those guys. Okay, now I have the t term, so I've got this 15 is actually going to cancel with this negative 15, so it disappears. This 14 is left over, so plus 14t. So I've done this, I've done the 14t, I've done the negative 15t. All right, and now I have 35 minus 12. So 35 minus 10 would be 25, minus another 2 will be 23. So I'll have plus 23 on the top, and on the bottom I'm going to have t squared plus 5t minus 4, and I'm going to square it. So the final answer there is going to be negative 3t squared plus 14t plus 23 over t squared plus 5t minus 4 squared, and that is the final answer. So you could expand this out if you wanted to, but you'd have a really large bottom and it would actually look more messy than it does right now, so it's perfectly fine to leave it like this. But notice, even though there are a lot of steps and a lot of algebra, the calculus part of it is pretty simple. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And that, my friends, is really why calculus has a bad rap. It seems really complicated, but really, you just have to be proficient at your algebra. Don't get scared off if you have negatives out there. Don't be scared off by simplifying terms and simplifying expressions. The only thing you did here with calculus is writing this business down and taking these very, very simple derivatives. The rest of it was just algebra. All right, and again, you could split this up into this guy multiplied by 1 over the bottom, and you could use the product rule, but it's just going to lead to more algebraic simplification, and it's just more straightforward to go ahead and use the quotient rule here. So we've done 3 good problems to give you a good idea how to use the quotient rule. We're going to stop the section now. In the next section, we're going to work some more problems, ratchet up the complexity a little bit, just give you some more variety. And I encourage you to practice these problems again to make sure you understand how to do them. Practice the odd number problems in your textbook so that you get some good practice. And don't be scared of the quotient rule. A lot of people worry about it, but if you just practice it, check your work, get proficient with your algebra and your simplification, then it's really not a big deal.
Learn anything at mathandscience.com.